meteor shower is Slooh's human spirit to talk all about that. Aquariid's meteor shower show.
Eta.
At
I'm not
Aquariids.
gonna use it.
I don't blame you one bit. Okay, let me just get this behind my head. Good evening, everybody, and welcome to Slooh. I'm Jerry Monteur, your host and expedition leader, as always, and tonight we are gazing up into the night sky, watching for meteors. It's the peak of the Eta Aquariids meteor shower. We've been streaming this meteor shower most of the day. We've already caught a bunch of meteors in our live feeds. So a big thank you to our friends at Weather News in Japan, who kicked things off with us this morning with live views of the shower just before dawn in New Zealand. Some gorgeous images coming from them. And tonight, we have feeds from a number of locations thanks to our network of observatory partners. We, of course, have live views from both our Canary Islands and Chile observatories here at Slooh. Throughout the night, you'll be able to look for meteors in our Chile all-sky camera, as well as through the all-sky in the Canary Islands. Also in the Canary Islands, we have some great low-light feeds from our constellation cam and from the camera perched atop the volcano Mount Teide. In addition to all that, we'll also be taking in a feed from France. Keep your eyes on our live feeds all night long and let us know on Twitter and Facebook if you spot a meteor. This shower is particularly active over the next couple of hours, so we're expecting to see plenty. Speaking of the next couple of hours, we have a lot of great stuff for you to enjoy. Not only will we provide these lovely views and a chance to spot a few Eta Aquariids for yourself, well, we've also got a great lineup of guests to help make your meteor watching adventure even better. Slooh astronomer Eric Edelman will be here to help us understand why these meteor showers happen every year and to explain what exactly comets have to do with it. Astronomy journalist and author Bob Berman will also be here to talk about the very special comet that causes tonight's shower. And speaking of comets, throughout the night, we'll be checking in on Comet 2015 V2, Comet Johnson, which Slooh members have been tracking all week long. And later, we'll talk to Slooh's human spirit editor, Helen Avery, to find out the fascinating mythological story behind the constellation of Aquarius, where these meteors seem to originate from. That's all coming up in just a few minutes, so don't go anywhere. Eric Edelman up next. And in the meantime, keep an eye on our live feeds and see if you can spot an Eta Aquariid meteor yourself. Stay tuned. We've been all over the world chasing solar eclipses to share with you. This time, you're coming with us. Join Slooh as we expedition to Stanley, Idaho to celebrate the transcontinental eclipse on August 21st. Sign up today at slooh.com. Space is limited. And we welcome you back to our Eta Aquariids Meteor Shower Show here on Slooh, Space for Everyone. We've got a terrific lineup of guests and, of course, our live feeds from around the world catching views of meteors all night long as they streak through the night sky. But what exactly are meteors? Why do meteor showers happen every year around the same time? And where did this one get its unique name? To answer those questions and much more, we turn to our friend Slooh astronomer Eric Edelman. Eric, welcome. Let's start with the basics. So what is a meteor shower?
Great question, and I would say, in a nutshell, it's a wonderful opportunity to look up at night. We have those days that are just a little bit better than others if you want to have a stargazing party. So we have the normal constellations that we can see at night. We have the planets, we have the moon, but then this gives us a little bit of a break from maybe what we would normally expect. So there's some space debris out there, some really, really small stuff, pretty much, smaller than a grain of sand.
Mhm.
Sometimes we get clumps of that stuff near where Earth is, and it starts colliding with our atmosphere. And that collision, well, it turns into those amazing streaks of light that we can see occasionally. It's not something we're going to see every second, but it's something that if you're patient, you take a little bit of time and a lawn chair and maybe some popcorn, you can see some really amazing things that are different from what's normal. Some streaks of light going across our sky.
So, why are these predictable? Why are there predictable patterns here?
So yeah, why do we have the Eta Aquariids every year at the same time? Why is the Orionids at the same time? Well, it's because we are going in circles, literally. So the Earth is orbiting around the sun, and it makes its journey every year, gets back to the same place that it was. And so the reason that we're getting these meteor showers is because there's just bundles of stuff, bundles of debris in certain places along the path of Earth's orbit. So around the same time every year, we're going to be in the same place where maybe there's a bunch of stuff to collide with. And so that's why, yeah, every time, every same month of the year, we're going to get those same meteor showers because we're just hitting the same place over and over again. We're going over things. We're never going anywhere new. There's no new horizons for us here. It's the same orbit, same time.
And these meteor showers, they all have peaks. Now, why is that?
They do. And so these trash heaps, these piles of space stuff, this space debris, it doesn't have a place. Well, it's not evenly dense. There's not the same amount of material at every place in the trash heap. There's going to be the giant trash pile that has the most debris, the biggest density of stuff. And so as we're moving through these heaps of debris, there's going to be a place where that meteor shower starts. So meteor showers, they actually can tell their stories to us here on Earth over the course of weeks. So we start to see the meteors sort of taking shape, and then there gets to be a point where there's a peak, where we're getting through the densest part of the material that's there out in space. And these peaks, they actually can vary a bit. Sometimes these peaks are very, very sharp. For this particular Eta Aquariids meteor shower, we're not actually going to get a very sharp, really strictly sharp peak. It's more of a gradual increase. Actually, over these few days is probably going to be the peak. Like if you went out and tried to look for Eta Aquariid meteors tomorrow, you might even have a good chance as well, because this is not, a number of hours being that really dense peak. So it has to do with the density of the material, and also beyond that, the location where they're coming from. So these meteor showers, they have these names to them, which are about where they're coming from. So meteor showers, they all have this what's called the radiant, where you can't always look at one spot in the sky and know that that's where all the meteors are going to appear. That's not how it works. But you can look at one spot in the sky, and that's where all the meteors will look to be radiating from. So there's going to be these streaks that appear across the sky. They're all coming from this one particular point, this one particular radiant. And all the meteor showers that we have, we've very straightforwardly named them after these radiants. So the Eta Aquariids, that is coming from the constellation of Aquarius. But where does Eta come in? That's more because there's a particular star in Aquarius where these meteors appear to be radiating from. So we get this very small radiant, and we name it after what's close by. So the star Eta Aquarii, that's where these meteors appear to be coming from. The Delta Aquariids, they come from Delta Aquarii, same sort of thing. They're not coming directly from that star, but look to be from our eyes, from our perspective, emanating from that point in the sky. And so the constellation of Aquarius during this time of the year is going to be rising a little bit before the sun does at dawn. So the best time to see these Eta Aquarid meteors is going to be in those early hours, right before the sunrise. So around 3 a.m., 4 a.m., that sort of deal. And so the peak can get even more specific, not because just of the density of material that we're traveling through, but also because of when we can see it at night. So this is a very much an early morning shower, and it has a bit of a sort of a gradual peak. But that's sort of, yeah, so you have to look at a lot of different factors when considering when best to view meteors from a particular shower.
Well, you seem to know a hell of a lot about it. Eric, is this one of your favorites? One of your favorite meteor showers?
Oh, my favorite meteor shower. And so that, I've actually, since this meteor shower has been coming up, I was thinking about that question a little bit. And can I say that a particular meteor shower is my favorite? And I think more than having saying like the Geminids or the Perseids is my favorite meteor shower. It's more about getting the right social experience together. If I have the right group of friends, we have the right food, we have the right location, we're out somewhere in nature. I think that's can be what really makes or break a meteor shower. Because sometimes if you're just looking alone up at night at the sky, that can be fun in itself. But really, getting the right social experience can be so fun, and that's and part of why I think these meteor showers here on Slooh are so great. Is because we connect with people around the world. We can see meteors at 3 a.m. somewhere else when it may be like 9 p.m. for someplace else in the world. So we get to see these peaks when it might not necessarily be the right time in our own sky. We get to talk with people in different places. So yeah, I'm have a bit of a cop out answer, but ones where I
No,
don't know, people get me to laugh the most, I suppose.
no, that's cool. That's absolutely a wonderful answer. Eric, thanks a lot. Stick around. You're going to be back in a few minutes to talk about comets. And coming up, astronomy journalist and author Bob Berman will be joining us to talk about some of his favorite meteor showers. He might be specific and offer a few tips on how best to enjoy one yourself. And later, Slooh's human spirit editor Helen Avery joins us to talk about the fascinating history of Aquarius, which Eric just mentioned, this constellation that gives tonight's shower its name. So don't go anywhere. Stay with us. Give the gift of the universe. Give the gift of Slooh. A celebration of every magical moment in the night sky. For just $60, you can give the budding space explorer in your life the gift of a full year of Slooh membership. It's available now at slooh.com. And welcome back to our live coverage of the 2017 Eta Aquariids meteor shower. I'm Jerry Monteur. And earlier in our show, we spoke to Slooh astronomer Eric Edelman to try and understand some of the basics about how meteor showers work and why. But Eric isn't our only authority on the subject, far from it. Here to tell us a little more about these celestial fireworks shows and offer a few tips to you meteor watchers at home is astronomy journalist and author Bob Berman. Bob, welcome aboard. What would you say is the best way to view a meteor shower?
Well, an open, expansive sky. I mean, other than Slooh, which makes it easy because we can be indoors, we could be informal, we could be in our pajamas if we want, and we don't have to be away from city lights. But if you're going to see it in person, yes, away from city lights, away from towns. If you have a backyard, great, but turn off the house lights so the sky is as dark as possible. And take in as much sky as possible. Some people make the mistake of trying to use a telescope or even binoculars. No, you want a wide swath of sky, and then the rest is easy.
Well, guess what, Bob? I am in my pajamas from the waist down. So listen, where does a meteor shower fall on your list of best celestial phenomena to watch?
Well, a really good one is in the top 5. Certainly, number 1 would be a total solar eclipse. We bring those regularly, and anyone who can travel to see one, and we're going to get one in America, of course, on August 21st. That's number 1. Number 2 would be a great display of the aurora borealis. Hard to top that. But right after that, it would be hard to pick between a comet, a great comet. They only come every 15 to 20 years, like Hale-Bopp and Hyakutake. We had those in 1996 and 1997. And then comes a great meteor shower, especially if it has some brilliant specimens and you get a few fireballs, maybe even a bolide. Love that word, means an exploding meteor. Pretty hard to top that.
Bob, does this one have the potential to be great?
It does. It's not, you don't think of it as one of the major showers of the year. The best, everybody knows the summer Perseids every August 11th and 12th. After that, you get the Geminids on December 13th to 14th. Once every 33 years, on average, you get the Leonids. And boy, did they perform in the wee hours of November 18th, 2001. That was the best meteor shower of our lives because you had about 5 a minute. And they all were bright, they all were green, and they all left behind glowing trains, like Cheshire cat smiles that remained in the sky that kept glowing for a few seconds before they disappeared. Wow, that was great. This one, well, somewhere down the list, but you know, when you see a great meteor, you ooh and ah, people gasp. They go, whoa, look at that. And it hardly matters whether that was one of 60 during that minute or the only one during that minute. You know, a good meteor is a good meteor. So that's what we're looking for.
So what's your favorite thing about meteor showers? Is it what you see, or is it the reactions from people that you're with?
Well, I guess that depends upon how unselfish our mood is that night. I don't know why people react to that, because they're only, most of the time, they're only swift moving dots going across the sky. Why should that make people gasp and go, oh my God, and reactions like that? The reaction in our, spirits seems disproportionate to what it is. You know, I can understand looking at Jupiter or Saturn through the great Slooh telescopes or a good backyard telescope. Okay, you go, whoa, or a total solar eclipse. But why does a meteor do this to us? I don't know why. And the synthetic ones, Jerry, just don't work. You know, in planetariums, sometimes they try to show a little zap of a meteor across the sky, and it thrills no one. But the live thing, the real thing in the sky, for some reason, that always gets oohs and ahs. Don't you feel the same way? You know, you don't get tired of them, not after 50 years.
Yeah, of course. It's like I always say, it's like the sky's coming alive, and I dig it. Hey, Bob, thanks so much for joining us. Stick around. You'll be back in just a little bit to explain how this particular meteor shower has a very special origin. And coming up, ever wonder about the stories behind your favorite constellations? Slooh's human spirit editor Helen Avery will be joining us to talk about the fascinating story of Aquarius. And then Eric Edelman returns to explain how meteor showers are actually caused by little bits of comets raining down from the sky. So stay with us. We've been all over the world chasing solar eclipses to share with you. This time, you're coming with us. Join Slooh as we expedition to Stanley, Idaho to celebrate the transcontinental eclipse on August 21st. Sign up today at slooh.com. Space is limited. And welcome back to our Eta Aquariids Meteor Shower Show here on Slooh, Space for Everyone. I'm Jerry Monteur. We've invited you here tonight to join in with the rest of our Slooh community in looking up at the stars and keeping your eyes on the skies for meteors. Meteor showers can be many things to many different people. They can be exciting, frightening, meditative, or even spiritual. And here to talk all about that and to give us a little insight into the history of this meteor shower is Slooh's human spirit editor, Helen Avery. Helen, welcome. Now, we've learned that this meteor shower comes from the constellation Aquarius. Is there anything special about that constellation?
Well, it's the 11th constellation of the zodiac. So if you're born around the time and you're an Aquarius, it's pretty important to you, I suppose. But it's a really interesting sign. So it sort of combines this. There's a water jug being poured into like a water's coming out of it, a water star, sort of a river of stars, and there's a person doing the pouring. So everyone kind of agreed. I say everyone. You know, the Babylonians saw this as a water jar being poured with someone pouring it. So did the Egyptians. And the Arabs didn't see a person, but they saw the jar being poured. And it was sort of, you saw this constellation around the rainy season. So it was sometimes associated with a storm god or a rain god. And it's also in the area of the sky that we call the ocean. So you've got a lot of watery constellations. There's Pisces nearby. There's Hydra, there's Cetus. So yeah, it was you know, that stage of the year where there was going to be a lot of rain. So this was often seen then.
And then we have the Greeks, Helen, and I gather for them, this constellation's myth is unique, right?
Yeah, it really is. As far as I know, it is the only gay love story up in the sky. So the one pouring the water to the Greeks was seen as Ganymede. And Ganymede was a very, very handsome, boyish, charming young man who caught the eye of Zeus. And Zeus sent his eagle, Aquila, to come and get Ganymede and take him back to Mount Olympus. Now, Ganymede was out walking one day and sees this eagle coming and is pretty scared, and so starts running, but he can't outrun this eagle. So the eagle swoops down, catches him, takes him back up to Zeus. And when Ganymede looks at Zeus and Zeus looks at Ganymede, it's this explosion of stars and love. And Zeus decides that because he wants Ganymede by his side all the time, that he will make Ganymede the water bearer. And back in those days, the one who poured the wine or the water into the cup of sort of the noble people, and in this case, the gods, was seen as very, very fortunate. So he appoints Ganymede to have this role, only the role is already occupied by Hebe, who is the daughter of Hera, who is Zeus's wife, or Zeus's queen. So Hera gets pretty upset about this and says that is absolutely not going to happen. And we all know that no one wants to feel the wrath of Hera. So Zeus instead says, I'll tell you what, I'll put Ganymede in the stars forever, so he and I can always be together. So, aww.
that is beyond sweet, and we were right. Unique too. So meteor showers they're pretty constant and they're very visible. So you don't need a telescope to see them, which means we've been watching them for centuries now. How did ancient cultures react to those showers?
It depends. Everyone sort of had something slightly different because it was something unusual in the sky. There was, as you know, you mentioned earlier, some fear and anxiety. For the Greeks and the Romans, they felt that maybe they're being punished. And I know we've talked about this before, but the night sky was seen as the sky was like seen as a dome, and beyond it was the palace of the gods. And it was believed that the gods' fireplace, ashes would like pop out, embers would pop out and burn a hole in this dome. That caused the stars to sparkle, so you could sort of see through to the fireplace when you were looking at stars. And it was thought that when the gods were angry with people down below, that they would push coal out, or burning wood, I suppose, out through the holes and then aim them at the people below. And that was meteor showers. So that's how they saw them. Now, Native Americans have many, many different myths depending on the peoples. And some saw the meteor shower as souls returning to the rightful place back in heaven. So it was like souls going into the afterlife. And then some actually said that you could, and I'm just going to quote here because it's really lovely. So this is the legend of the Menominee people of the Great Lakes region. When a star falls from the sky, it leaves a fiery trail. It does not die. Its shade goes back to its own place to shine. The Indians sometimes find the small stars where they have fallen in the grass. Which I love this idea of seeing the stars fall in the grass. And then the other thing they were seen as, and this is sort of the early Christians and Muslims, saw the meteor showers as gifts from angels falling down from heaven.
Wow, that's beautiful. It is.
It is, right? Better than just, debris from a comet.
Yeah, really. It could be nasty, but it's not. My favorite thing about meteor showers is when I look up and I see in the night sky, I see, to me, the sky coming alive. It's like it's making a statement. What's your favorite thing about meteor showers?
I'm with you. For me, it's that, often when we look up into the vastness of the night sky, we're met with stillness, which is why it's sort of a very meditative experience. But then when you see things moving, like shooting stars or falling stars, we're reminded, of this aliveness of the universe, and that we're part of that aliveness, and things are happening all the time. So I really love that. And then the other thing I love is that, as I just mentioned, falling stars or shooting stars or meteor showers are debris from comets. And I kind of love this idea that comets discard the stuff. They don't want it. Off it goes. It's just thrown away. And then, millions and millions of miles away, someone's lying on a blanket, in a meadow, and they see this debris from a comet, but they don't see it as something just discarded and thrown away. They see it as this like source of wonder and something to wish upon, and a sort of something to think about the universe. So I love this idea that, the imperfect perhaps is a source of wonder and love for someone somewhere. So yeah, lots of feels from the meteor showers.
Sure, as it should be, All right, Helen, as always, wonderful stuff. Thank you, and we'll talk to you soon, okay?
Okay, thanks, bye.
If you enjoyed that segment, you can find so much more human spirit conversation going on in our community content section. Just go to slooh.com, or if you're here already, just look below this video for some of the fascinating things our members have shared about meteor showers. Coming up, did you know that meteor showers are actually caused by comets? Yes, you already knew that. Of course, we'll find out more when Eric Edelman joins us once again. And speaking of comets, there's a very special comet causing tonight's shower. We'll talk to Bob Berman about the role Halley's comet plays in tonight's spectacle. So please stay with us. Give the gift of the universe. Give the gift of Slooh. A celebration of every magical moment in the night sky. For just $60, you can give the budding space explorer in your life the gift of a full year of Slooh membership. It's available now at slooh.com. And we welcome you back to our Eta Aquariids Meteor Shower Show here on Slooh, Space for Everyone. I'm Jerry. We've got a terrific lineup of guests and, of course, on live feeds from around the world, catching views of meteors all night long. Now, we know comets cause meteor showers, but what makes this particular comet so unique? What are they made of? How often do they get so close to us? We have so many questions, and only one guy at the moment can answer them, and that is Eric Edelman. We welcome you back. All right, Eric, back to meteor shower 101. What causes them? What causes meteor showers?
So things getting crazy with littering, the litterers of our solar system, in which particularly, as you mentioned, the major culprits tend to be comets. And so sometimes when these comets get really close by to us, they get lazy, they litter, they don't use the proper trash receptacles, and we get a bunch of debris, some trash heaps in the middle of Earth's orbit. And that's when those trash heaps collide with Earth's atmosphere. That's when we get our meteor showers. So yes, very lazy astronomical bodies, essentially.
Okay, then what are comets made of?
Comets, they are dirty snowballs. So they're made of a lot of sort of dirty rocky material and also things like water, ice, carbon monoxide, methane, ammonia, volatiles, things like that. And so what happens is that these comets, they have oftentimes very elliptical orbits, sort of like a stretched out rubber band. And so these comets, they can get very, very far away from Earth in the center of the solar system. A lot of them hang out in a place known as the Kuiper Belt. That's out past the orbit of Neptune. And they can even head out even farther away than that. But just, it's a crazy, crazy distances. But a lot of the ones that really contribute to the meteor showers that are well known, famous, are very easily witnessable today, have to do with some of the ones that are closer by, like in the Kuiper Belt. And here we have a beautiful, beautiful comet on the screen coming to us live from the Slooh observatories. This is Comet C 2015 Johnson. So it shows you sort of what a comet looks like. This is a gorgeous example of it. So we see sort of this bright sort of center region and then this sort of gas that's outflowing from that comet. Because these comets, what makes them so unique and so prone to litter is their tails. They have these outflowing of both gas and debris, and so the dust and gas tails. And so these dusty tails, they get very long, very large, the closer these objects tend to get to the sun and the sun's rays, because this sunlight, when they get close by, it really heats up these comets. It gets them hot, and then they start to outgas. The gassy material starts to escape from the comet, and the rocky material sort of trapped between this frozen gassy stuff is released as well. We get this debris tail that comes out as well. And so as this comet travels through the solar system really close by to the sun and has these extreme beautiful tails, that dust tail, that can leave a lot of debris, the trash heaps that we end up experiencing as meteor showers. So yes, this is a gorgeous example of the process of how we get these meteors streaking through our sky, seeing it right there live on the screen. That's a beautiful view.
Okay, so these debris trails or debris tails, are they all basically the same, Eric?
They can be different. So comets can be made out of different things. And so we can also have these debris piles that are moving at different speeds relative to our planet. So some meteor showers we get really fast shooting stars. Other ones we get are a little bit slower. And so the position of the debris fields, how densely they're packed, things like that, they can affect how we experience meteor showers. Because like this meteor shower, the Eta Aquariids, this is one where, depending on your latitude, you get something between 10 or 30 streaks of light per hour, sort of the expected in a really, really dark sky. But you can get other meteor showers that have less than that, maybe 5 an hour, maybe more than that, 80, 100 an hour, and that can have to do with, the density. And so density, speed, material, this can all change from comet to comet. And we actually get a lot of interesting information with this meteor shower of maybe studying sort of what's involved with this comet, what it's been doing, and it helps us to learn about this comet's past by seeing the debris it's left behind.
So how often do comets typically cross our orbit?
So there's comets with lots of different orbits. The Earth orbit crossing comets. Those are the ones that we often can attribute to meteor showers. And there are different types of comets that are coming by. So there's ones that have, they're short period comets. They're like, for example, the Eta Aquariids being the progenitor comet being Halley's Comet. That comes by every about 75 years. And so those are considered short period comets. I know that sounds like a long time, but then we have comets that are way farther away from us than these Kuiper belt comets. These are ones that could come from, say, the Oort cloud, which can be something around a light year away from us. These are comets that can take tens, hundreds of thousands, millions of years to make an orbit, extremely long period. And so the ones that really make the meteor showers that are famous for us are the ones that are short period, like Halley's Comet, that come by every few decades to sort of replenish their trash heaps, their debris fields, and so that we continue to get those meteor showers over many, many cycles, many, many years.
So do meteor showers ever run out? Do they ever stop showering? Can they go extinct, for lack of a better term?
Yeah, it's very possible, because when a comet litters, it doesn't litter an infinite amount of material. So as we go through that debris field one year, we're going to take some of that material away. And as we continue to go through that debris field every year, getting another shower, we're going to continue to deplete that material more and more. And if that comet does not come by fast enough to replenish that material before it's all gone, well, then you're going to run out. And so that has to do with why we have short period comets, mainly being the progenitors of the showers that we experience here today. Because the longer period comets, ones that take maybe tens of thousands of years to return, maybe they went and crossed Earth's orbit once, and now tens of thousands of years later, we've run out of that material. So it's easier for a shower to stay hip, constant, alive when it has this comet that keeps coming back to replenish that trash heap. But interestingly enough, when we're experiencing the Eta Aquariids, we're experiencing debris that's centuries old. We're not experiencing the latest flyby from Halley's Comet, scientists have measured. It was in 1986, I believe, that they looked at the amount of stuff that was coming from the Eta Aquariids when Halley's Comet passed by. They were looking to see if there was going to be an increase once Halley's Comet zoomed by and deposited more material. But interestingly enough, they did not see that increase. So there's the possibility that perhaps Halley's Comet might have been slightly adjusted in terms of its orbital position relative to Earth's orbit, so that we're not getting that debris field directly in our path anymore. So things can change in a lot of ways, even with short period comets. It's a very interesting study.
Yeah, it is. Good stuff. Good stuff. Great info, Eric, as always. Thanks a lot. But we need you one more time. So you'll be back in just a few minutes to tell us how we can listen to meteors as well as watch them. And coming up, Bob Berman returns to continue this comet discussion. We'll be turning our attention to the most famous comet of them all. That, of course, is Halley's Comet, which is the reason this meteor shower exists in the first place. So stay with us. We've been all over the world chasing solar eclipses to share with you. This time, you're coming with us. Join Slooh as we expedition to Stanley, Idaho to celebrate the transcontinental eclipse on August 21st. Sign up today at slooh.com. Space is limited. And welcome back to our Eta Aquariids Meteor Shower Show here on Slooh, Space for Everyone. In our last segment, we learned from Eric that meteor showers are actually little pieces of comets burning up in the atmosphere, which is pretty neat in and of itself. But tonight's shower is caused by a very special comet. And here to tell us more about it, once again, Bob Berman. Bob, which is this very special comet for those who weren't listening earlier?
The most famous of all, of course. People say Halley's Comet. I no longer correct them. It was taken after Bill Halley and his Comets, that 1950s rock group that made rock around the clock. But no. Halley is probably how Edmund Halley pronounced his name in 1805. This is when he made his famous prediction that several comets that were seen in antiquity, and this one has been observed since the Chinese saw it in 240 BC. He said that several of these separate comets were really one and the same. It was easy for him. He was pals with Isaac Newton. How many people can drop that name in a party and say, oh yeah, last time I spoke to Isaac? But he was such good pals with Isaac Newton that he found in Isaac Newton's desk drawer a physics paper, the Principia, and said, Isaac, you've got to publish this. Turns out to be, has proven to be the greatest physics book ever in the history. And it was Halley who got his pal Isaac Newton to take it out of his drawer and publish it. Anyway, so in 1805, he realized these were several separate comets. He predicted it would return in 1758. It just barely made it in time. Came back on Christmas Day, 1758. That's because Jupiter and Saturn tugged on it and slowed down its return. But nonetheless, he gets full credit. except that he had dropped dead in, I believe, 1742. So he never lived to see the comet return when he predicted it. But it was a big deal, Jerry, a big deal, because people did not know that comets were like planets, that they went around the sun, that they thought they were meteorological objects, things in our atmosphere. Actually, like meteors are, the meteors we're seeing tonight, but they thought the comets were also. So the French astronomer said we should name this after him. And so that's how it got named Comet Halley. It's also called P for periodic 1. It's the first, it's number 1 of the periodic comets. Comes back every 74 to 75 years. I brought a group down to see it when it last was around in 1986. What a disappointment. It was the worst visit of Comet Halley in 2,000 years because we were on one side of the sun and Comet Halley was on the opposite. Too bad, a bummer. When it comes back next, Gary, that's why you should keep eating these health foods and work out in Maine, where you live. Keep working out, because in 2061, it's going to next come by, and Comet Halley should give us a good show. And then the time after that, in the year 2137, we should have the best visit in the last 3,000 or 4,000 years. So here's a comet. We're looking at a comet, but the best is yet to come. We just have to stick around long enough to see it. But right now, it's almost as far away as it can get. It goes out as far as almost the orbit of Pluto. It gets to 35 AU. So it's way out there. Really, really distant. It was just spotted a few years ago, magnitude 28, which is close to the same brightness that a cigarette would have on the moon. If the astronauts, it was a no smoking zone, but if they did smoke on the moon, that's how bright a cigarette would look from Earth on the moon, as bright as Halley's Comet is now. And yet telescopes picked that up. Pretty good. We do pretty well these days.
So, Bob, the history and the celebrity status that Halley's Comet has attained through the centuries, it's all part and parcel of what makes it so special, right?
Oh yeah, most famous comet. Also, it goes the wrong way. You know how everything goes around the solar system counterclockwise. If you're north of the equator, north of the Earth looking down, all the planets go that way. All the moons of all the planets, except for just one, the sun rotates that way. It's a one-way solar system, but not Comet Halley. Halley's Comet goes clockwise around the solar system, which means that if it hit us, it would be about the most violent possible collision you could ever have, because it's coming straight toward us. It's going the opposite way around the sun than we are, and that's why its fragments are also very fast. These at 40 miles a second, these are among the fastest meteors that we're seeing tonight, that of any. You know, they're rivaled only really by the Leonids on November 18th. Perseids aren't too bad, but they're a few miles per second slower. So odd comet, unusual comet, fabulous comet.
All right, Halley's Comet, and there's the 411 from Bob Berman. Bob, thanks a million for joining us tonight. Have a good one.
Pleasure, Jerry. Thank you.
Coming up, Eric Edelman back to tell us what this blue window is all about and explain how you can hear meteors even when you cannot see them. So stay tuned. Hey, Trish. And welcome back to our live coverage of the 2017 Eta Aquariids meteor shower. We are watching our global live feeds, hoping to catch a glimpse of some of these bits of fiery space debris as they streak past our low light cameras. But even if we couldn't see them, we could hear them. Eric Edelman returns now to tell us how that is possible. Okay, Eric, and everybody at home, in the upper left-hand corner of your screen, you see "Listen for Meteors Live." What is that?
So yeah, we're taking advantage of as many senses and many human senses as we possibly can here tonight. So looking with our eyes, but also listening with our ears. So this is a radio frequency that we're looking at here. There's a lot of noise that's going to be happening right now. We're seeing a visualization of the audio that we're going to be hearing. So a few steps removed, I know, but so if you can look, you can see maybe a little bit of a line sort of going down the screen, that blue screen, to the right side. And so we're going to be looking to see if there's any maybe bright spots there. That's going to indicate to us that there's maybe a meteor that we're hearing. And so it's a very complex subject, but I'm very happy to get into it. What's going to be going on is that, so hearing radio waves, that's a very interesting subject. So we have this whole electromagnetic spectrum. We can see with our eyes, Roy G. Biv, we can see the rainbow. But then beyond the rainbow, there are higher energy and lower energy wavelengths of light that we can't see. The higher energies being things like gamma rays, lower energies being things like infrared light and radio waves. And so these different energies of light are being produced all throughout the universe, some heading right towards us here on Earth. And then we have this atmosphere that surrounds us, this atmospheric onions of layers. And so some of those layers reflect some of those energies of light away from us, back away. So we don't get a lot of the gamma rays because of our atmosphere. We don't get a lot of infrared light because of our atmosphere. And it works the same way inside here on Earth. If we produce any infrared light or gamma rays, they can be reflected back down on us. There are windows in the visible spectrum of light where we can get visible light from way out there in the cosmos. We can also there's a certain hole in the radio side of things. Only a very certain part, though. So AM radio waves, they're in a place in the spectrum of light where they actually tend to get reflected back down by the atmosphere. FM radio waves, they're not quite in that region. So, a place around 50 to 150 megahertz, for those of you in the know about radio frequencies, those are the places that sort of can zoom past the clouds, get away from our planet up out into space if we release them here on Earth. Except if there are very special circumstances. So there's a place in our atmosphere that's known as the ionosphere. And so meteors, when they come into our atmosphere, we see this streak of light, and it's not actually the meteor itself that we're seeing. So the meteor is actually compressing and heating the gas of our atmosphere around it. So the bright light that we're seeing is this hot ionized gas in the ionosphere. And interestingly enough, the FM radio waves, the waves around 40 to 150 megahertz, if they hit that ionized tail, instead of usually like they go all the way out into space, they actually get reflected back down to Earth. So we can actually hear FM radio at a greater distance away from the normal emitting station than we normally could. AM radio waves, they have a longer range to them. FM are usually shorter. So what we do here is we have this listening device. We have this antenna that's listening at a very particular range of frequencies. And normally it's going to be hearing a lot of noise. So when the audio comes on for this radio feed, you're just going to be hearing something like if you turned on the radio to a static channel, something that didn't have any radio channel nearby broadcasting to you. Except there might be points in time where you hear a bit of a burst, a bit of a pop, a bit of a louder sound above that normal noise. And that would happen if we are hearing a very distant station that is, say, reflected off of that meteor trail. And so we're hearing a meteor occurring in our atmosphere. There's a lot of things that are going on here, but that's just a little bit of a short explanation of what's happening.
Did you happen to notice the little blip, the line that went down the left-hand side of the of the scroll just a few seconds ago, Eric.
Oh, I missed out on that, but a little bit left of the major line, right?
Yeah, it was it's quite a bit left of the major line. I don't know if you noticed that. So, yeah.
Oh, for that, an interesting thing is that you might be seeing not just that vertical line, but you might be seeing a little bit of a horizontal line as the reflection is off a range of frequencies, because there's going to be a little bit of a Doppler effect with the fast moving.
So what's the dot on the left there?
The dot on the left, it could be just noise. It could be, like, for example, different things going on in the atmosphere. So there's one example of a phenomenon known as like sporadic E's, where there's some ionization that's happening up in the ionosphere that kind of can make the meteors a little bit harder to hear, because there's other activity going down that can be reflecting the frequencies that we're listening at. We're particularly listening at, I believe, 61.26 megahertz for those of you that are interested. But yeah, what you want to be looking for is a bit of a quick sound, and also something that maybe has a little bit of a quick, maybe like a check mark sort of look, a bit of a horizontal movement to it as well. And so the more you listen for it, the more you might get used to what you're trying to find. It's a little bit of a learning curve to it initially.
And we're liable to pick up something besides meteors? Is that what you're saying?
I mean, there's a possibility. There's a lot of things going on in the atmosphere. So what you're not looking for is we hear the noise, and then all of a sudden we hear this really long-lasting, maybe like 30 seconds, a minute long, an hour long, of just this signal or something like that. That wouldn't be a meteor. The meteor is going to be very, very short-lived. It's going to be a very short ping. And so there are other things that this radio feed could pick up on, but you're looking for that short little blip, the one that might span a little bit of a range of frequencies.
Okay, we'll keep our eyes and ears peeled. Eric, thanks as always. Great stuff.
So nice talking with you, Jerry.
All right, that about wraps it up for us here tonight on Slooh. Dawn is starting to break at our Canary Islands observatories. Thank you so much for joining us for this year's Eta Aquariids meteor shower. Now, while the show may be ending for us, it's still going on wherever there are dark skies. If you live anywhere where it's still dark out and you have somewhat clear skies, head outside and look up, and you have, well, preferably in the last couple hours before dawn, you have a pretty good chance at seeing something. If you're in the southern hemisphere, you're pretty likely to see a meteor. Folks up north will have a harder time, but it's not impossible. If you do see a meteor, let us know. Even better, set up a camera and see if you can capture one. Then send it to us on Twitter or Facebook, or post it to our community content here on slooh.com. You can join in on keeping an eye on all things happening in space, from meteor showers and comets to the sun, the moon, the planets, by making a reservation on our telescopes in the Canary Islands and Chile. Any paying member can reserve time on all of our telescopes, looking live at stars and planets and galaxies and nebulae and all manner of celestial objects. And members also get plenty of chances to watch our featured content here in the Space Situation Room. We do this all the time here at Slooh, and coming up, there are plenty of chances to tune in for some great shows. Next week, we'll be celebrating Buddha Day, learning all about the importance of the moon to Buddhist celebrations and the calendar. And a little later this month, we'll be celebrating the dark skies and all the magic they bring. We'll be talking about light pollution and speaking with people who live in protected dark sky communities to find out how life is different when you grow up under the stars. That's all coming up here on Slooh. So join the community, interact with other members, and tune in. But for now, thanks for stopping by. I'm Jerry Montour. You've been watching Slooh, Space for Everyone.